All right, this last problem here, the last example, really just has a whole bunch of nonsense. It says assume the following nonsense, okay? So none of this really, is anything important. Just numbers and allows us to use the dimensional analysis to solve. So it says there are 15 maps per one car. Okay, so I don't know why you would need 15 different maps in a car, but there you go. There are 70 Twix per three crunch bars. Wow, that's a lot of Twix. Okay. And then there are two cars per six crunch bars. Hmm, interesting. So what I did here is I just wrote all this information down. So 15 maps per one car, 70 Twix per three crunch, and two cars per six crunch. So I started by just writing everything down in a ratio format. Then it says create a question that uses at least two of these facts and then answer the question using the information. So we want to come up with a question that uses at least two of these facts. So you can't ask a question about maps and cars because that just uses one fact. You can't ask a question about cars and crunch. You can't ask a question about Twix and Crunch. You gotta use two different of facts. So I can ask a question about Twix and maps. So I can say, how many Twix are there per map? Okay, again, I'm just picking one. It's no real big reason. Um, so how many Twix will there be? So how many Twix per map? So that's my question, and here's all my information. So I'm starting with Twix, Twix per map. So I'll just go ahead and start with this here. 70 Twix per three crunch. And I don't have any other Twix references, so I have to start with this one. Now, I do want to get rid of crunch. So this one doesn't have crunch, but this one has crunch. All right, so I'm going to put crunch on top. You can just flip these. It's not that big of a deal. So I'm going to put crunch on top. I'm going to say 6 crunch over 2 cars. That lets me get rid of those crunch. Now, I have cars. I really don't want cars. I want maps. Okay. So now I got to come up here. So I'm actually using all 3 of these things. All right. So remember, you just have to use at least 2 of them. Um, Now I want to get rid of cars, so I'm going to flip that. I'm going to put 1 car on top, and I'm going to put um, 15 maps on the bottom. That lets me get rid of the cars, and I'm left with maps and Twix. And it's actually Twix per map, and I actually have Twix on top, so it'd be Twix per map. So that worked out pretty well. Now I'm just going to multiply my numerator, so I have 70 times 6 times 1. So that's just 420. So I have 420 Twix. But that's total. And remember, I have 3 times 2 times 15 still. So 3 times 2 times 15. That's going to be 90 maps. And I want to just do per one map. So we're just going to divide by 90. So I'm going to take 420 divided by 90. And, you see we got a decimal here. So that's 4.6 repeating, or you could say 4.7 Twix. So, again, this is an estimate. So 4.7 or, about 5, maybe 4.7 Twix per one map. And again, it's not going to work perfect because we're just coming up with a random question given a bunch of random data, right? So it's okay that we end up with a decimal there. Um, But just make sure you're carefully going through and getting rid of the labels that you don't want and keeping the labels that you want by using dimensional analysis.